Hey everybody, here's a video intro into how to handle derivatives that involve natural log of x. So basically, we did e to the x, now we're going to do the inverse of that, which is natural log of x, and figure out how to manipulate it, from a calculus perspective. Well, in order to do that, we need to know what the derivative is. So let's just suppose we let y equal natural log of x. Well, we can do some manipulation to this to try to figure out what its derivative is by exponentiating both sides. So basically take e and raise it to both sides of the equation. If you remember back in your algebra 2 days, natural log of e and e to the natural log are again inverses of each other, so you end up with simply x. So e to the natural log of x is x, just like the natural log of e is 1. Okay, so e to the y is what's left over on the other side. And if we go ahead and take the derivative here, we can use our chain rule. So it's e to the y times y prime, right? Derivative of e to the x is e to the x, but this is an x, this is y, so we need to do a chain rule. If you think back to when we did implicit differentiation, that's essentially what's happening here. Derivative of y is y prime, and of course that equals 1. Well, let's solve this for y prime. That's 1 over e to the y. And we said e to the y is actually x, so guess what? The derivative is 1 over x. So the derivative of natural log is 1 over x. And that's essentially the rule. Now, it's not always going to be natural log of just x, of course. Just like all the other functions we learned about, sometimes we're still going to need to use the chain rule. But this is the basic idea. So an example here would be something like, suppose we had y equals 5 times natural log of 3x. So our derivative, this is just a constant, so it's going to be 5 times the derivative of natural log of 3x. Well, it's not just x, it's 3x. So the rule says 1 over, what this thing is. So this is natural log of x, so 1 over x. This is natural log of 3x. So it's going to be 1 over 3x times the derivative of that thing, which is 3. So this is really no different than, if it was like sine of 3x, right? The derivative would be cosine of the thing times the derivative of that thing. It's just a different rule. It's going to be 1 over whatever's inside the natural log here times the derivative of that thing. Now, when it's just x, the chain rule would just be a 1, so we don't have to worry about it. But obviously, that's not what's happening here. And then, of course, the 3's would cancel, and you could simplify it as just 5 over x. And that would be the final answer for that derivative. All right, let's try another one. I'll leave this up there like that. Let's try, suppose we had y equals the natural log of 1 over x. Okay, well, this says take 1 over whatever the thing is. So my derivative is going to be 1 over 1 over x times the derivative of 1 over x. Well, 1 over x, don't forget, is the same as x to the negative 1. So the derivative would be negative x to the negative 2. And then we can just simplify from there. 1 over x is just x times negative 1 over x squared. That's going to simplify a little bit to just negative 1 over x. And that would be your final derivative. All right, let's try another one. How about, what if we had something like this? All right, hopefully you realize we're going to need a product rule for this one. So we'll go ahead and do the derivative of x squared, which is 2x, leave the natural log alone, plus leave the x squared alone, derivative of natural log is 1 over x. We can simplify that a little bit. So this would become 2x natural log of x plus x. And I guess if this is a book problem, they probably would factor out the x, leaving you with 2 natural log of x plus 1. This would be okay. This isn't really that bad. But if you're checking the back of the book, or if it's a worksheet answer where the answer came from the back of the book, it might look like this. All right, so hopefully that'll give you a good idea of how to approach these. This is the basic idea here. Just remember that a lot of times the chain rule comes into play simply because it's not always going to be just x here. And if you need any more help with anything or have any other questions, be sure and ask. And hopefully you guys are doing great, and we'll talk to you soon.